that more is better didn't have to deal with wrangling data in the age of big data. The explosion of data from everything we do has become a monster that grows in complexity the more it consumes. It gets bigger, slower, and wilder with every byte. Taming this beast hinges on turning the tangled mess of data that created it into something that flows. Something elegant, agile, easy to use. It means crafting solutions that bridge the operational and analytical divide. This is where you shine, filtering and corralling the unruly. You transform, reshape data so it calms down. Plays nice has high value downstream. In your hands, data overload becomes a strategic advantage and data chaos gives way to clarity. Behind the curtains, it's your designs and code. Your ability to collect, process, and restructure data into meaningful new forms that wills the beauty in the beast and the best in what software can do.
Please welcome to the stage Confluent's Chief Product Officer, Sean Klaus.
Good morning, everybody. I'd love to extend a really warm welcome to everybody joining us here in this packed auditorium and everybody joining us live online. Kafka Summit Bangalore 2024, the first ever, is officially open. And we have a tremendous lineup of different presentations, announcements, and breakouts for you around all things data streaming. You know, we're so excited to bring Kafka Summit to India for the very first time. India is an incredible hotbed of innovation around all things to do with data streaming. I mean, just this morning on the show floor, it was incredible to see so many people and hear about the incredible, innovative things that all of you are building using Apache Kafka and the entire Kafka ecosystem. You know, at Confluent, we're really big believers that streaming forms the foundation for something that is truly transformative for businesses everywhere. We want to empower you to do more with your data more easily than you ever have before. And to us, honestly, that means going beyond just helping you stream, although we know that streaming is itself incredibly powerful. We want to help you go beyond a few business-critical use cases. We want to help you go beyond the niche of speed and real-time and to deliver that transformative impact to your organization. Now, ultimately, to do that, we have to address the way businesses approach all of their data and their data infrastructure. And to do that, we first have to acknowledge what data and data infrastructure usually looks like. Honestly, it's pretty chaotic and it's kind of messy. Why is that? Well, it's because your business requirements, those requirements that form the story of your applications, your infrastructure, tend to come together one need at a time. Every time you have some new data need, what do? You wire up the destination, point to all of the different sources that it needs. Have a new mobile app? Add some wires. New features in the web app? Add some wires. Each new need, more wires. And over time, your data infrastructure starts to look like this giant, tangled mess of interconnections. And beyond just being really complex, these links are actually surprisingly brittle as well. Take a common example. Let's say a system upstream changes. The schema drifts. Data is no longer compatible in the way it once was. What happens then? Well, all of the systems that depend on that data break. And sometimes they do so loudly in the middle of the night, but sometimes, even worse, they do so silently and undetected for a long time. And all of the systems downstream from those systems break, and so on. And yet, your one-by-one data needs and business requirements keep coming faster and faster. One day, you need some new mobile app features. The next day, you need some AI inference or classification. It just goes on and on. And so you keep adding those brittle connections. And we have to keep up not just with the rate of change, but with the rate of change of change. Now, for all of you developers in the audience, I hope you'll recognize that I'm not just talking about some sort of abstract architectural set of problems. I'm talking about things that you would experience as real-world developer pain. I mean, have you ever had a data pipeline that had been working fine for ages suddenly break because a team 2 cubicles over has changed their system in an incompatible way, and they didn't even think about the consequences for all the other systems in the ecosystem? Or have you had to deal with the developer who's 2 seats away from you, who keeps pestering you about what the fields of your message mean, how they should interpret them, and whether or not they can rely on them? As intractable as some of these problems might feel today, this is actually as easy as it is ever going to get. It will only get harder from here. Imagine all of these problems when you have 10 times as much data and it's all being used to feed AI features. It's really obvious that doing more of what got us here won't get us there. Can we do this differently? Can we address these point-to-point brittle connections at their root? Can we untangle the mess? Well, I think that we can, but it's not going to be by continuing to do what we've been doing. We're going to have to do things differently. And I think that's true in 2 major ways. We have to move from a world where all of our data is connected point to point to a world where multiple subscribers can connect to and take advantage of the most important data in our enterprise. And second, we need to go from a world where data consumers reach into source systems and suck out the data they need to a world where the producers present well-formed, valuable, reusable data to other consumers in the ecosystem. Now, this isn't really a new idea. If you've heard some of these ideas before, or you've read about it, or even implemented them, you might recognize that I'm kind of talking about the concepts that the industry refers to as data products. Now, data products are actually relatively simple in conception. They can be as trivial as a well-formed data set that exists in a mutually accessible location and has a set of owners that are responsible for creating it and evolving the data set. Now, data products are meant to address the problems that cause the data mess at its root. So, you might be wondering, okay, if there exists a well-known industry concept, I mean, literally there have even been books written about this topic, then maybe we're on our way to solving the problem. Maybe this is literally just a matter of implementation lag. Sadly, that isn't the case. The common approach most of us have been using towards data products has actually suffered from a literally fatal flaw. What's the flaw, and how do we address it? Well, for that, we have to dive back into that data mess. Now, within the data mess, there are actually 2 separate but highly interconnected estates: the operational estate and the analytical estate. The operational estate is where your online applications work together to deliver your business processes and power the experiences that your customers and your employees take advantage of. And then we take all of the data from the operational estate, we suck it out, we move it over to the analytical estate, where we try and piece it back together to understand what is happening across the business and make good business decisions. Now, the thing about data products is that the approach we've been using in the industry has really focused entirely on the analytical estate. And that kind of makes sense, because when they were first conceived, they were kind of thought of as an idea to try and make sense of all of this data across this tens or hundreds of systems from the operational domain and try and put back together into a business meaningful view. But ultimately, all of those data products are still being created from data that was born in the operational estate. And the operational estate does not even know that they exist. So a trivial change in the operational estate can break all of those beautiful data products we have spent so much time creating. And what really adds insult to injury is that those data products are often difficult or impossible to take advantage of back in the operational domain. And that means that when you have your developers and your architects building new features or capabilities or adding new AI capabilities to your applications, they're often stuck using the point-to-point brittle connections they've always been stuck with. So really, when we've been talking about data products, and we've been doing that for a long time, we haven't really been talking about data products. We've actually been talking about analytical data products. And that's really like sweeping a mess, in this case, a massive data mess, underneath the rug. But what we really need is a different type of data product. We need a data product that can work in the operational domain, the analytical domain, and between the two. We need a universal data product. So if a universal data product is what we need, how do we get there? Well, the good news is I'm not describing some sort of architectural promised land. We're not going to go and have to write a book about this to describe how to even create it. You can actually create universal data products using the technologies you already know and love. You're probably using them today. A universal data product can be as simple as a Kafka topic with a well-defined schema that describes the shape and meaning of the data, and a set of owners that are responsible for the creation and evolution of that data set. Now, the best bit is these data products are just as reliable, reusable, and discoverable as those data products we have been talking about for such a long time. But they can be used in any estate, the operational estate, the analytical estate, and between. So if universal data products can be that easy, you might be like, OK, how can I scale this approach across a massive estate, all of my different applications and the data of my organization? Well, for that, you need the capabilities of a data streaming platform. And there's 4 key capabilities. Let me walk you through how they make universal data products easy. The first capability is the stream. Now, we're at Kafka Summit, so I'm not going to sit down and try and explain to all of you what streaming is. You all absolutely know what I'm talking about. But what's important to understand in the concept of universal data products is that streams are the perfect foundation upon which to federate data access across your applications and your analytical use cases. And there's 2 key reasons for that. The first is that streams are inherently real-time capable, which means that they are compatible with the needs of your operational estate that usually does work in real time. It might be OK if an analytical report or a strategic analysis is a few hours old, but your customers are not going to accept their experiences being full of inconsistent, incoherent, or out-of-date data. They want it to be real-time, and they just want it to be easy. So ultimately, low latency must be a capability of the foundation upon which we're building these universal data products. Now, second, the cool bit about streams is that they are just as reusable as these other data products we've been talking about. And they enable many subscribers to connect to the exact same data and use it for their use case. And those subscribers can do it either in real time, if they need it that way, or they can do it in batch. It doesn't matter. Now, that removes all of those redundant point-to-point links that cause the data mess in the first place. And it lets many different systems and users connect to the data as it flows through your organization. Which brings me to Connect. For a data product to be truly universal, it has to be compatible with all of your systems, whether those systems exist in the operational estate or the analytical estate. You want to be able to reach any source system and push data to any sync system, and the data streaming platform makes that super easy. Now, obviously, it's not good enough to just be able to connect to your data and to be able to stream data between all of your different systems. You also need to be able to govern your data. Now, when I say governance, most people immediately think of trustworthiness and reliableness. And that's absolutely true. You can't build a castle on top of sand. And so the data streaming platform makes it easy to apply schemas to make certain that your data remains the same shape, a reliable shape that can be understood by others. It makes it easy to apply data quality rules so that you can be sure that the semantics of the data do not drift and teams can rely on it. And it provides lineage views so that you can know where did the data come from, where is it going, and how is it being used. But honestly, governance is as much about opening things up as it is about closing things down. Once data is reliable and trustworthy, then you can catalog it in a data portal so that it can be discovered and understood by teams all throughout your organization. And it's only then that your data can really reach its true potential. You can't hide your data under a rock. And finally, you also need to be able to process your data. You need to be able to give it all of the rich domain context it needs to be a truly high-value data product. Now, obviously, raw, full-fidelity streams in real time are incredibly valuable. But downstream teams can move much more quickly and with higher confidence when they know that upstream teams have prepared the data, enriched it, evolved it, and made it really usable with all of the domain context that, honestly, they're the best set to have. So, with all of those capabilities applied, how does the data mess look now? Honestly, it looks a lot cleaner. Now, if you check out the flow on the screen right here, you can see that you can still see the Kafka topics that you know and love. But now they're being joined and connected with other data from all across your organization to create really high-value data resources. And it's those Kafka topics, when they are made trusted and easily discoverable, that create the exact universal data products I've been talking about for this entire talk. Now, we're no longer in this constant battle where we're wrestling with point-to-point links and brittle data. We're not in this vicious cycle where our data keeps getting away from us and complexity is unbounded. We're in a virtuous cycle where data sets become more than the sum of their parts, and they're available for teams everywhere to put to work the moment that they are created. And the very best part is that as you do this, teams will consume these data products to power their use cases, and they themselves will create more data products that make it faster for other teams in your organization to deliver the innovation that all your businesses need. So, the 4 capabilities of a data streaming platform make universal data products easy. Let me quickly recap how. Firstly, we connect to any data system, whether operational or analytical, in source or sink. And by doing so, we set all of the most important data in your organization in motion as streams. We make those streams trustworthy by implementing quality controls and governance checks. And once the data is trustworthy, we then catalog the data so it can be discovered by other teams that can then consume it for their use cases, whether those cases are in real time or in batch. We enrich those streams by stitching, evolving, and improving the data from across your organization to produce really high-value data assets. And that's it. You have those universal data products that every system, every application, every team can take advantage of. And you can take those data products and power any use case, whether it's an operational use case, a mobile app, an AI use case, an analytical use case, a report, you name it. So, have we solved those developer pains that I talked about right at the start of this talk? Well, we have. All of those data pipelines randomly failing, not anymore, because data is now reliable and reusable all across your organization. And what about the discussion with the developer 2 seats over who's trying to figure out what your data means? Now they can self-serve and they can understand it and take advantage of it. So you guys can spend more time talking about the IPL and less time talking about your data. But OK, enough about the IPL. Let's get into a little bit more detail about how all of these capabilities work together. And for that, I'd really like to welcome my colleague and friend, Addison Huddy, who's been hard at work on the streaming capability of the data streaming platform, which we call Cora. Please welcome Addison Huddy.
Thanks, Sean, and good morning, everyone. I'm absolutely thrilled I get to speak with you all about streaming at the very first Kafka Summit Bangalore. I've been working on Apache Kafka now for about 6 years, and I gotta say that this community is pretty incredible. With a large and robust community behind it, Apache Kafka is the de facto standard in streaming. All the major cloud providers, multi-billion-dollar startups, and thousands of developers are working each and every day to make this project amazing. There are over 150,000 organizations using Apache Kafka in production. Apache Kafka has 27,000 GitHub stars, and y'all have hosted over 1,500 meetups all over the world. It's pretty incredible. In fact, the Apache Kafka community just celebrated its 1,000th Kafka Improvement Proposal, or KIP. That's 1,000 times this community has come together to do something amazing. And I want to tell you about some of my favorites. It's not news that Apache Kafka doesn't require a zookeeper anymore, thanks to Craft. And yes, I want to set the record straight. It's Craft, not K-Raft. But regardless of how you say it, Craft is GA and ready for production. Quick reminder, Zookeeper will be removed and Craft will be default in Apache Kafka 4.0, so if you're self-managing, get upgraded. I'm also a huge fan of KIP 848, which is a ground-up rewrite of the Kafka Consumer Group protocol. Not only will this make consumer group rebalances super fast, but it's going to lay the groundwork for future innovations. And not to be outdone, the broader Apache Kafka community that maintains dozens of Kafka clients just collaborated on a brand new Confluent-supported JavaScript client. So all you Node developers out there, you can stream too. And what KIPs does the community have in store for us in the future? In short, a lot, but I want to highlight topic directories, two-phase commit, and queues for Kafka as my personal favorites. Shout out to Andrew Schofield on the team. He's somewhere in the audience. He wrote a 90-page KIP for queues for Kafka, and I know the team is hard at work on implementing it with the goal of getting it into Apache Kafka 4.0. Now, I could talk to you about Apache Kafka all day. But I want to switch gears and talk to you all about the lessons I've learned operating Kafka at massive scale in Confluent Cloud over the years. And lesson one is putting Kafka in the cloud isn't just putting Kafka in the cloud. Before offering a cloud service, Confluent only shipped on-prem software. That's where you package up some jars, and we give it to you all with instructions on how to run it. Now, there's nothing inherently wrong with this model, but we are limited in how much we could help you. Confluent changed this more than I could have imagined. Cloud gives us the opportunity to be right next to you on your streaming journey. It's a paradigm shift that required us to revisit first principles and build from the ground up. So we got to work. Roughly 5 million people hours over 5 years went into building Confluent Cloud, and we're still going. And at the heart of it is a brand new cloud-native streaming engine that we call Kora. And even though Kora is still delivering Kafka, it does it in a unique way. First, Kora solves the problem of delivering a managed service to thousands of customers across tens of thousands of clusters. Kora gives us massive economies of scale and, in turn, allows us to deliver our product at a great price. Next, Kora needed to work across cloud providers. Each of the hyperscalers is a bit different, and Kora needed to work across different cloud networking, storage, and compute technologies. Last, but most importantly, to deliver the most reliable Kafka service, Kora needed to automate operations so problems could be solved at machine speed, not human speed. All of this is table stakes for delivering a reliable, secure, and cost-effective cloud service. Now, I'm not going to have time to go into all the details of Kora, but I encourage you to read this white paper that won Best Industry Paper at VLDB 2023. Now, what can Kora do for you? Kora has allowed us to deliver a faster, more reliable, and cost-effective Kafka service. Now, hitting your performance SLOs are hard, and you need a service that's fast. Less than a year ago, we announced that Kora was up to 4 times faster than Apache Kafka. And here we are, less than a year later, and Kora is up to 16 times faster than Kafka. As you can see from this graph, for this open messaging benchmark workload, we measured a 16x improvement on P999 end-to-end latency. So at Confluent, resiliency is product priority number 1, and Kora allows us to deliver on this objective. Our 4.9 SLA is 10 times better than other Kafka services. That's why Micho, SAP, and Goldman Sachs all trust Confluent Cloud. They trust Confluent Cloud because it just works. Now let's talk about costs. Confluent has helped nearly 5,000 customers save on their Kafka costs. And the beauty of serverless is that as Kora gets more efficient, we can pass on these price performance savings on to you. There's no upgrading, no migration. The cost savings just roll out to you. Now let's talk about elasticity. Kora's cloud-native architecture is built on top of S3, allowing us to deliver a scaling experience that's super fast. So whether you're dealing with the demand of a major cricket match, the stock market opening, or one of the biggest shopping days of the year, you can scale up quickly, all the way up to 30 gigabytes per second of throughput. Now, right-sizing Kafka, or any critical infrastructure for that matter, is a tall order. If you under-provision, well, you run the risk of an outage. If you over-provision, you're paying for more capacity than you need. Over-provisioning is far more common, and I can tell you that I routinely see Kafka clusters that are 2 to 3x over-provisioned. Worse yet, I work with customers that before moving to Confluent Cloud needed to spend months planning some big workload increase, and then subsequently months spinning that down, costing them a lot. With Confluent Cloud, thanks to Kora, it makes capacity planning super easy with something called a CKU, or Confluent Unit for Kafka. Want more capacity? Just provision more CKUs. Want to provision less? Take CKUs away. Seems pretty easy, right? But we knew we could do better. And recently, we took our serverless and elasticity to a whole new level, from minutes to milliseconds. Last year, we announced a new way to experience Confluent Cloud with elastic CKUs, or eCKUs. Compared to regular CKUs, elastic CKUs auto-scale instantly, up and down, shaping your workload. There's no more waiting for hardware to provision, no more idle resources, and no more paying for more than you need, because with eCKUs, we'll only charge you for what you use. eCKUs are available on our basic, standard, and enterprise clusters. Now I want to talk to you about different workload types. Kafka is used for all sorts of amazing use cases. Some require ultra-low latency, like microservices orchestration or stream processing. Others don't require nearly the same ultra-low latency, like log aggregation, metrics, or telemetry. I want to talk about the ones on the right. For those really high-throughput use cases, running Kafka at scale can be very expensive, especially because of networking and inter-AZ costs. Now, at scale, networking can be 80, 90% of the total cost of running Kafka. Now, we could just build a single-zone cluster, but that's not going to give us the availability that we need. Or we could use something like S3 Express one zone, but heck, that's more expensive than just replicating the data. Given that Kora is a cloud-native engine built on top of S3, can Kora save us money here? Today, I get to talk to you about something really special making its debut in Confluent Cloud, a new Confluent Cloud cluster type called Freight. Freight clusters offer low-cost networking for relaxed latency workloads, making them the perfect cluster type for logging and metrics use cases. Put simply, if your workload has a second to spare, you can save a lot. How much? Compared to Apache Kafka with Freight, you can reduce your Kafka spend by up to 90% by not paying for the low latency writes you don't need. Why the name Freight? Well, like a freight ship, the data gets there more slowly than, say, air travel. But the marginal cost to move a byte of data is far less. Let's see how Freight clusters work. Here's Kora's architecture from that VLDB 2023 paper I mentioned earlier. Now, Kora is always evolving, so let's zoom in and take a look at some of Kora's next-gen features. Part of Kora's 16x latency improvement over Apache Kafka is thanks to a super fast inter-AZ replication mechanism. It's great, it's really fast, but it costs a lot. The next generation of Kora now has the ability to bypass cross-AZ replication and rely on S3's native replication for durability. These writes have higher latency because we are waiting on S3, but are much less expensive. It's a good trade-off for those logging, metrics, and telemetry use cases I talked about. And with Freight, it's still serverless. So there's no complicated agents, brokers, or disks that you have to manage. And with Freight, it uses the same eCKUs that I was talking about earlier. Auto-scaling up and down, shaping your workload. So you only pay for what you use. Freight clusters are now in early access on AWS. And go to that QR code to sign up. And for all your other low latency use cases, the other 4 Confluent Cloud cluster types offer our industry-leading ultra-low latency performance. So building on our plane and ship analogy, Confluent has a cluster type to meet any workload on any budget. So that's the foundation, the stream. Now I'd like to touch on connect, because what good is streaming if you can't connect all your systems together? Confluent Cloud has over 80 fully managed connectors for the most popular systems. And for all the other use cases, we have a custom connector framework that you can build on, and then we'll run the connector on your behalf. There are 3 recent announcements to connect that I want to highlight here today. Number 1, we now offer outbound private link across our connectors for AWS and Azure, making setup easier and secure. We've launched 3 fully managed Debezium connectors to CDC data out of Postgres, MySQL, and SQL Server, and an OpenSearch connector and a DynamoDB connector. And finally, we've reduced our throughput pricing on our connectors by up to 50%. Okay, so we've talked about Quora. We've talked about saving money with freight and EC2s, and we've talked about connecting all of our systems together. But what about governing all this data? For that, I'd like to introduce you to my colleague, Keshav Ramarao, who's going to talk to you all about streaming governance.
All right, yeah. Thank you, Addison. Good morning. Now that we have our most important data coming into streaming, let's talk about governance. Why governance is so critical for managing streams at scale. As Sean said earlier, governance isn't about locking down data. It's about opening up. Too often, our teams seem to be in an endless tug of war with our data. Isn't that true? On one side, security team is always trying to protect our data, keep it safe, and on the other hand, developers want to build net new applications to create value for business. But I don't think tug of war is the right metaphor. I would like to think it's more like the box of cables that we all have at home in a storage, right? Imagine that you have to pull out a type A USB cable so that you can charge your old phone and take out all the photos before you trade in for a new one, right? I'm sure all of us have done that. But when you pull at this mess, it gets even more messier, isn't it? The analogy that I'm trying to draw here is each of these cables are like our own bespoke data streams. And the more you pull at it, it gets messier. So now, how do we solve this continuous problem? So each of these data streams have its own schemas, policies, and there are different levels of maturity, and then they have been built for specific purposes within the organization. And all the time, new developers join our organization, and they are tugging at this mess for net new unknown purposes all the time. This happens all the time, right? But the problem is, only a smallest portion of our organization really understands this mess. And that's crazy, isn't it? It's our data. We have built it. We've been using it. Our developers who built this know the purpose, know the structure very well. So if we can offer a way to inspect, untangle the data, view the data flow end-to-end, we solve this data mystery. We need to harness this tribal knowledge that each of our developers have to make the lives of the developers and the security teams better. How can we achieve this? In order to achieve this, we need to shift our governance thinking to the left. Where? Into streaming. We think about governance for only data at rest. We should be, on the other hand, that's a legacy mindset. On the other hand, we should be thinking for governance for data in motion. Streaming is our first point of contact with the data, and it serves both our operational and analytical estates. And it's always connected to everything, right? So the best way to untangle our data is to do it from the beginning, where it lands into our data estate, which is streaming. Streaming is where governance should begin. After all, the cleanest data is always bottled at the source. So how do we really do this? First, we need to ensure our streams are of high quality. We need to have schema that defines the structure of our data, and we need to have rules that validates the quality of data. So shifting data quality to the left enables our developers to land the data in an untangled manner the very first time, so that the rest of the organization can make use of that data. Once we know we can rely on these data streams, we need to know more about them, isn't it? Our stream catalog provides the ability to describe technical metadata as well as business metadata to deliver even more context. Context like what? Context like description, data owner, sensitivity, production, non-production tags, classifications. This not only helps our developers to discover the data products better, but it also helps our security team and compliance team to identify sensitive data and enable masking so that before it gets shared out with the data, it's protected. So finally, we need to make sure we know where the data is coming from and where it's going. So to do this, we have our Stream Lineage product. It's our own Google Maps for data. It helps not only in understanding and troubleshooting the current state, but it also helps to go back in time to see how the schema has evolved over a period of time. So when we pull all of these things together, what do we get? We get a data stream with validated quality, with metadata, and with full lineage. So we get the markings of a great data product. And since it's a stream that works both for our operational and analytical estates, it's a universal data product. So for our security and compliance teams, it helps with data standardization, reusability, redacting the sensitive data from the beginning. And for our development teams, it helps with discoverability, it helps with tracing, and it helps with changing the data without breaking the downstream systems. So now, isn't this great? Isn't this awesome? So if you have built these data products, don't we want to share this internally with other teams so that they can get the benefit of the data products that we have built, maybe in an internal marketplace, without compromising on security and agility, right? That's exactly what we would like to show you now, Data Portal. It's a very simple interface to publish data products in a self-service manner and consume it in a self-service manner. So now I'm happy to invite Jai and Ajay onto the stage to show you just how easy it is to build these data products with streams of governed data.
Cool. Thank you, Keshav. Hello, everyone. Today, Ajay and I are going to demonstrate some of the coolest features in stream governance. Let's consider a scenario where we both are a part of a retail business company that sells clothing. Specifically, I'm going to play the role of a data owner acting as a data producer, and my friend Ajay is going to play the role of an application development team member acting as a data consumer in the same company. Without any further ado, let's jump into the demo. As you can see on the screen, this is a stream lineage view. With the help of stream lineage view, you can understand how our data platform has been set up. On the very left, you can see the fundamental data sources generating a lot of data into the different data topics that we have set up. The data from these topics are further processed and enriched using Flink before it is sent to the final destination topic. In short, the stream lineage view acts like the Google Maps for data in Confluent Cloud. Now, our data team actually built a data product to identify the top trending products. The data from orders and products topics were processed using Flink before it was pushed to a topic called as top selling products. Now let's have a deeper look into the orders topic. As you can see in the right side panel, we not only show the technical metadata like messages in, messages out, bytes in, bytes out, the number of partitions or the type of schema, but more importantly, we also show what is this topic being used for, the business metadata, right? With the help of topic description. What are the associated tags, which will help us classify the topics, and who is the owner of this specific topic. Even more, as a data owner, I can actually view the messages that are flowing into this topic in real time. I can also view the schema of this specific topic. Remember, schema is the starting point of a data contract. In this schema, you can very well see that there is a field called as confirmation code. This is the field which we use internally within our retail company to understand whether if a product purchase was successful or not. Now, when our data team was building this specific data product, there were certain data quality issues. Especially, the confirmation codes were not correct for certain orders. Now, how did we overcome this data quality issue? Well, the data quality rules came to the rescue. This is the data quality rule that we have set up. On the screen, you can see that we are matching the confirmation code against a regular expression. In case if there is a match, then it is a good record. In case if it doesn't match, then it is identified to be an erroneous record, and it gets routed to a DLQ topic named as bad orders. Now let's have a quick look at the bad orders topic. There you go. In real time, the data quality rule has actually acted on the erroneous record where the confirmation code didn't match the regular expression that we had set up, and it has routed to the specific DLQ topic called as bad orders. Now with that, I hand it over to Ajay to walk us through the consumer experience.
Hi, everyone. I'm Ajay Krishnan, and in this scenario, I'm part of the application development team. So the business owners have been requesting us to build a widget which shows the top trending products on our e-commerce website. So how do we go about solving this problem? How do we even find the access to the right data? Well, I can go and search some databases that I have access to. I can go and search some internal corporate wikis, some Google Docs that everyone creates, nobody updates. I can troll through some Slack messages. But what if there is a better way to find the available trusted data sources? Well, this is what the data portal solves. On the screen, you can see the data portal, which is the quickest way to locate the trusted data products. At the top, I can do a free-form text search based on the topic name or the tag name. I can also filter the topics based on the tags listed. Let's click on the data product tag. OK, this has narrowed down the number of topics quite a bit. I see a topic named top selling products. Let me explore that a bit further. We can see some of the metadata fields that we just discussed, like the description of the topic, the tags associated with the topic, who the owner is. I can also view the lineage associated with the topic. OK, so I can see that the top selling products is getting its data from the product and the orders topic. OK, I think I have located the right data. Let me request access to it. As I'm a consumer, I only want to read from the topic. I don't want to write to it, so I'll click on read only. I'll also add some message so that the data owner gets some context as to who is requesting access and why they are requesting access. Let's initiate the request. What this will do is it will send an email to the owner of this topic, which is Jay in this case. So he'll get an email saying that somebody has requested access to the top selling products topic. He can see some context there. OK, so now he wants to review the request. This will take him to the Confluent Cloud portal where he can see all the requests which have been pending. OK, he can see my request. Now he can approve access. Got it. OK, so let's go back to the data portal now. So I've been searching, locating, and requesting access right in the data portal, right? As a consumer, I did not have to go anywhere else. So yeah, we can see that I have some more actions available. Like I can set up a client to read data from this topic. I can query data using Flink. And I can also set up Flink action. So it seems that I have found access to the right data using the data portal. So to summarize, as data owners, we started with building high-quality data products using the data contracts. We located these high-quality data products as consumers using the data portal. And the best part of what I showed you today is that everything is available for free. Which regions, you ask me? It is available in all regions. What do I need to do to get access to this? Nothing. It's enabled by default. And with that, I would like to thank Jay and invite Mayank to the stage to demonstrate how Flink can enrich this data and make it more valuable. Thank you.
Namaskara, Bangalore. It is so good to be back in the city that I called home for almost 6 years, and what better occasion to do it than the first ever Kafka Summit India. Now, you've heard a lot about data streams today, about governance, and as we think about shifting governance to the left, we need to think similarly about processing as well. It's stream processing that allows us to take the data flowing through an organization and process it in real time. And by doing it ahead of your sync systems, your data stores, you benefit on a few fronts. First, you can eliminate the often redundant and inefficient processing that's happening on your downstream systems. Second, it allows you to build apps on high-quality data that won't break because of some upstream schema change. And third, and probably most obviously, you sometimes need answers faster than batch processing can provide. And if you believe that stream processing is the right paradigm, which you should, given that you're on streaming conference, then the question becomes, what is the right tool for it? And there we have a clear answer. It's Apache Flink. Flink has become the de facto standard for stream processing in the market. And Kafka users have certainly taken notice. If you compare Flink's adoption with that of Kafka, you'll notice that it's actually separated by just a few years, but it follows a very similar trajectory. And that's not by accident. As data streaming users mature, they realize the value that stream processing can bring on top. And when we encounter Flink in the wild, it's more often than not bookended with Kafka. You know, Flink jobs read from a bunch of Kafka topics, they process it, and then write into Kafka topics as well. And this combination of stream plus stream processing, which is really Kafka plus Flink, is so powerful that it's at use in some of the most technically sophisticated companies in the world, including Netflix, Apple, and a bunch of others. But if you're still thinking, why Flink in particular? Well, that's because you can solve any use case at any scale with Flink. You can use analytics, pipelines, applications, and AI for any use case imaginable, such as personalization, inventory forecasting, business monitoring, and much more. And before moving on, I want to talk about this one thing that's increasingly part of all use cases, and that's AI. Now, the big buzz in AI is specifically around GenAI. And GenAI is great for out-of-the-box questions like, who won the 2011 Cricket World Cup? But it can't help customers trying to adjust their personal trip to follow their favorite IPL team. For that, you need a pattern called Retrieval Augmented Generation, or RAG. RAG brings business-specific context to the foundational models. And Flink and the data stream platform are critical here, because it allows you to locate that data, transform it, and make it available in a vector store for real-time processing. But hydrating the vector store is just one part of the story. Let's take an example of a RAG-enabled chatbot. For any RAG-based application, the second critical step is to orchestrate calls to these foundational models and that generate responses based on contextual cues coming from the vector store. Now, to make this a reality within Flink, I'm proud to announce that models are now first-class resources in Flink, just like tables and functions. What that means is you can write a SQL statement to create a model in Flink and then pass that resource as an object to the ML predict function that will then generate responses based on the configured prompt. And you can call any model, not just a foundational model. And of course, we want to work closely with our open source community to make this a reality, and that is exactly what Flip 437 aims to do. And with this, I'm proud to announce the early access of AI model inference in Confluent Cloud. You can scan the QR code to file a request, get an early sneak peek, and we'll reach out. Now, if you're thinking, sweet, this is available in open source, so let me just download it and try it out. Well, you should. But the only catch is this. If you thought self-managing Kafka was hard, managing Flink was even harder. But I did say was. Not anymore. 1 year ago at Kafka Summit London, we announced the early access of a fully managed Apache Flink service on Confluent Cloud. In the months that followed, we worked with our early adopters to gather that feedback and include them in our roadmap and plans. We then announced the public preview at Current, which enabled hundreds of our customers to build POCs. And we got a really good feedback on that. During that time, we have continued to integrate with the rest of Confluent Cloud, governance in particular, and expanded to multiple regions. And more importantly, we have hardened the service for 4.9 SLA. And we're doing this in a true cloud-native fashion with no clusters, elastic autoscaling, and scale-to-zero pricing. So I'm very excited to share another milestone, and this is a big one. It's the general availability of Confluent Cloud for Apache Flink. And to make the deal even sweeter for this audience, we have announced 4 new regions in India so you can bring Flink closer to your data. Now, it's been an intense year to get to this point, and we'll never stop improving our service because it means that we can be of more help to your teams in solving your use cases. But you don't have to do this alone. Our global ecosystem of system integrator partners are here to help you design, solve, and implement these use cases. And when it comes to connecting to other parts of the ecosystem, the connectors that Addison spoke about earlier is going to help you get data in and out of this data streaming platform. So this GA is very exciting news, and it will make Flink more accessible to even more users. But we've talked a lot about universal data products. And the question is, where does Flink fit in? Right at the heart of the concept. I mentioned earlier that processing left makes your organization more efficient. But that can seem a little theoretical. Let's take the real-world example of you going into a retailer, a shoe retailer, to try your favorite sneakers. And you get this. Now, what is this? This is a box of unassembled shoe ingredients. Now, if I go into a shop to buy a shoe and I get this, I'll be pretty mad. And I hope so will you. Now, you want the whole thing, but you get only the parts. And this is exactly what a lot of data patterns like ELT are about. Dump a lot of data parts onto the end systems so that each destination and each destination user gets to process the data. Does that make sense? No. Whether it's shoes or data, we need to take the raw products, have experts process them into intermediate products so that a different set of experts can take those intermediate products and create something further downstream. And that's exactly what universal data products enable us to do. The people closest to different aspects of your data, be it clickstream, orders, shipments, they are responsible for offering out data that is the most relevant and well-formed. And stream processing makes this 1,000,000 times easy and more secure. And it's not just about efficiency, it actually promotes creativity as well, because employees can then spend more time thinking about the use case and less about hunting for the data. Now, I spoke about our GA product earlier, and I want to reiterate that that product is Flink SQL specifically. And SQL is an amazing language for data transformation. It just makes the core things we do so much simpler. And that's exactly what we want, the simple things to be simple. But we also want the hard things to be possible. We want you to bring your arbitrary business logic and be able to use that in Flink. And that's where Flink's user-defined functions and table API come into play. Flink SQL includes broad support for user-defined functions, which allow you to call out external APIs, do custom aggregations, custom windowing, and essentially do any arbitrary business logic. And this is exactly what you see on screen, a Java code, which is a UDF, and it is being invoked in Flink SQL. So I'm thrilled to announce the early access of Flink user-defined functions in Confluent Cloud. Feel free to scan the QR code. We're still taking entries, and we'd love to work with you. But if you want to write Flink applications in Java or Python, or even mix and match these languages with SQL, Table API has you covered. Table API in Apache Flink provides a high-level, declarative programming interface that simplifies the development of streaming and batch processing applications. So stay tuned as we bring Table API to Confluent Cloud very soon. So we've learned that Flink is not just SQL, and of course, Confluent is not just in the cloud. Production Flink jobs have been co-deployed alongside Confluent Platform for years. And to reduce this friction in self-managed deployments, we are bringing Apache Flink to Confluent Platform, starting with a limited availability in our upcoming 7.7 release. Our Confluent Platform Flink offering will support not just Flink SQL, but a broad range of features, including the data stream API. So existing Flink jobs can be deployed on Confluent right away. Confluent is bringing Kafka and Flink together everywhere, whether you're self-managed or fully managed, on-prem or in the cloud. If you're interested in self-managing Flink on Confluent and want to participate in this limited availability, reach out to us. We'll be happy to talk. OK, that's a lot of me talking about the product, right? Now, let's see some of this in action through a demo, starting with Flink Actions. Now, what if I tell you you can write a stream processing job without writing a single line of code? Well, seeing is believing. So let's get into it. This is the familiar data portal screen that you saw earlier. I'm going to click on the clickstream enriched data topic, and I'm going to inspect the message here, right? So if you look at the schema, there is an IP address field which is sensitive, and I want to mask it. So what do? I go to Actions. Now think of Actions as commonly used, prepackaged data processing steps that you can spin up in a matter of clicks. So I click it. And you have deduplication and masking fields to begin with, many more to come. For this example, we're going to talk about mask fields. And this is super simple to set up. You click on mask fields, you provide the field that you want to mask, you give the regex, add a couple of other configurations, which is essentially the compute pool, and you'll be good to go. So you hit confirm. Now, it's doing two things here. It's first creating a destination topic where the masked messages will go. And second, it's creating a Flink job that would automatically process these messages and push them into this topic. Now, let's see if this actually works, right? To do this, we'll go into the SQL workspace in Confluent Cloud and hit a simple select star from the destination topic query. Let's see what this brings us. OK, and as you can see, all the masked messages in the topic. So I told you we wanted to make the simple thing simpler, and honestly, stream processing doesn't get simpler than this. But I also want to show you Flink SQL in all its glory and how to use a UDF along with it. And for this example, I want you to imagine the last time you bought a shirt online. And it came, but it didn't fit because the brand's large was really a medium. And so what helps in this scenario is, of course, an analysis that the brand typically runs smaller. And this is exactly what we're going to do here with UDFs. But we want to write some custom code to compare strings for it. So what you see on screen here is a Java class that defines a scalar function that would take in two t-shirt sizes and output true if the first one is smaller. The next step is to just compile this into a jar, this artifact that we will use further. We'll upload this artifact into the Confluent Cloud. And the next step is to call this create function statement that would reference this uploaded jar and the class name that has the function. And so this is going to register the function in the Flink catalog. And to see if this is available and ready to use, let's hit this query with some sample data. And as you can see from the results, it works, right? So the UDF is working. We are on track. The next step would be to actually create an intermediate data product that would hold data for all the products that were repurchased within 1 hour of being returned. And that's the data we are interested in. So we go for a create table here. And this will create a topic and a schema underneath because that's the metadata integration within Confluent Cloud between Flink and Kafka. So we've done this. It's ready to use. Now we need a streaming query that will incrementally update this data product with the latest data. And so I'm calling it the hourly orders materializer. It's an insert into statement. And the cool thing is that this is an actual Flink job running continuously on the latest Flink runtime, auto-scaling based on the workload, just out of the box. So now we have our data in this intermediate data product, right? And we are ready to do some analysis. We'll write a query that will use this UDF. We'll first do a temporal join to enrich this data with the brand's information that's in the product's topic, and then use this UDF in the in the where clause and get a count of the number of times the brand runs smaller by using a group by. Now, if we hit run here, you will see the results. It is a count per brand, and this is a constantly updating result set that you can feed into a topic or power a dashboard. OK, so that is the end of the SQL demo. But I know you don't want to use the UI for deploying production jobs, right? And that's where the Confluent Terraform provider has you covered. You can now use the Confluent Terraform provider to securely manage and deploy your production Flink applications. OK, I can literally talk about Flink all day, and that's probably my plan for the day. But right now, you got to give it up for our next speaker, Kreps.
It's great to be here. Can everybody hear me? All right, there we go. It's great to be here. There's really incredible energy every time I come to India, and I'm so excited that we finally get to have a Kafka summit here. And I'm also excited about the new Flink product that you just heard about. I think that's an incredible piece of technology. We put together the team that worked on that probably over a year and a half ago, and it brought together some of the core team that had built Apache Flink. It brought together people who had built cloud data warehousing, people who had worked on large-scale stream processing, and I think they built an incredible product. And part of our mission at Confluent is to make streaming the default, the way everything is done. And part of that is making stream processing really easy. So I'm really excited about just the trajectory of what's happening there. But it's not just Flink. Really, you heard across the data streaming platform in each of these major areas pretty significant new pieces of functionality. In the core of Kafka, you heard our Cora engine and all the innovation there. The fact that it's now 16 times as fast as Apache Kafka. You heard about freight clusters. In Connect, you heard about private networking, some new Debezium connectors for Postgres, MySQL, SQL Server, a ton of new functionality that's coming out. In governance, you saw the data portal, which I think is incredibly great as a way of sharing data across an organization, and the integration of Flink into the governance functionality. But when it comes to our efforts, it's not just about features and functionality. It's not just about adding more tools. It's also about cost. We want to make streaming and stream processing cost-effective for all the use cases. And you heard a lot about areas where we're trying to drive better TCO, lower pricing, lower cost for all our customers. Our philosophy is when we drive innovation in our product and our stack, we want to pass that on to everybody that we're working with. And so you heard about the 90% TCO reduction with freight clusters. I think that opens up a whole class of use cases for a fully managed cloud product. You heard about the 50% price reduction on throughput for connectors. You heard about the entry-level governance, which is now available free in all regions for all customers. And maybe most excitingly, you heard about the Flink offering, where it scales down to 0, scales up elastically, so you don't have to provision some big cluster ahead of time and hope you use it. You pay for just what you need. So I think it's a lot of exciting stuff, but that's not all. There's something I want to talk about here at the end. One more thing. And that's about unifying the world of operations and analytics. You heard from Sean earlier about this idea of the operational estate, all the things that run the business, and the analytical estate, all the data processing and reporting and analytics in the back end. Let's talk about how these actually come together. And I want to talk about something new that can help make that even better. So let's zoom in on these areas. Let's start with the operational estate. This is all the things that run the business. It's all our custom applications, the bits of SaaS tools that we've adopted, all the databases. And we all know in this area, as Sean talked about, there really is a big data mess. But we have a solution. You know, we're here at Kafka Summit. We know all about this. There is really an emerging de facto standard of how this all knits together. And this is happening at scale in companies all over the world. And that's Apache Kafka. Kafka is very much the open standard for integrating across the operational estate. But when we look at the analytical estate, it's a little bit different. So Kafka is often the feed of data into this area. But when we think about all the different tools here, they actually end up running on top of not really just streams, but mostly big tables of data. Big stored tables of data. That's what a data warehouse is, a data lake. All of these are oriented around these tables. And historically, in the analytical area, all of these tables have been siloed in different vendor-specific tools. Each data warehouse is its own little island. But that's been changing in recent years. There's been a move towards open shared tables that are stored in cloud storage. And the de facto standard for that is a technology called Apache Iceberg. This is something which makes it possible to create open tables and share them across all the different tools that might want them. So what is Iceberg? If you haven't heard about this, I think it's a really exciting technology. It's actually quite simple. It's not a complicated thing. It's just a simple layer which defines the metadata format to take the files you would have in an S3 or other cloud storage and present them as a table. and do that in a way that is efficient, that allows strong typing, that allows columnar representation, and that opens that up in a way that can be accessed by all the different tools you have, from Snowflake to DuckDB, all the things that want to work with and access that data. And increasingly, this is the way a lot of the parts of the analytical estate are interacting with data. This is how they're integrated. So now, back to our original question, how do these two areas come together? Well, this happens today. It's very common that you would take the streams of data in Kafka, and you would write them out into Iceberg. And you would do this stream by stream. But this isn't a perfect setup. Today, the way people do this, it's mostly just a surface integration. And there's actually a lot of pain to keep this running. And the reason for the pain is because of all the diversity of data. Almost anything that happens in the business needs to end up in the analytical estate. So all the streams we have in Kafka have to get mapped over into our data lake or lakehouse or data warehouse. And often that mapping is incredibly detailed and error-prone. We talk to customers where there's hundreds of little Spark jobs, each taking some event stream and trying to parse out the right fields to put into a table. And it works until it doesn't. As soon as something upstream changes, that Spark job may fail, if you're lucky. Or it might just send bad data downstream to a lot of processing, and days are spent trying to clean it up after the fact. So this is not the ideal situation of how these things come together. So what if we could do this better? What if we could actually properly unite these two areas and provide real integration between the streams and the tables, really converge the streaming world with the batch world? This is actually not a small project to do it for real. But it's something we've taken on at Confluent. And we have a really exciting product that I want to talk about that does this. And to do this, you have to actually integrate across 3 major layers of the stack. This has to cut across the underlying stream that has the data. It has to cut across the governance and into the processing layer. And this is exactly what we've done. And so in the stream, we've made it possible to have the exact same data, like literally the exact same S3 files that are shared between the Kafka topic and the Iceberg table. So you can have the same data shared in both. In the governance area, we've made it possible to share the same schema automatically, so that the schema you would have for your Kafka topic propagates down to the table. And in the processing area, the same engine, Flink, is able to do processing across streams and tables, from batch to stream processing, and unite those two. So that's a lot. Let me dive into what it all means. I'll start with the stream layer. What does it mean to actually share at this layer of the stack? How is that possible? So ultimately, as you know, you would store data in Kafka. The Kafka topics have a large amount of stored data. And if you're copying that out into the data lake, you're putting it into some S3 files. But as you heard from Addison, the architecture of Quora is ultimately also based around object storage. All that topic data is there in S3. It's actually already represented there. And so if it were possible to somehow share that with the table and not have to have it twice, that would be more efficient, it would be easier, it would be more automatic. And that's exactly what we've done in the core storage engine of Quora. We've actually taken this real-time stream, this commit log of events that's coming in, and we've made it so that you can have a transformation of that with the same exact files that actually makes that available as a structured table. And this duality between streams and tables, this stream-table duality, this is a common thing in the world of stream processing. It's a known thing. But it's actually been made a physical part of the underlying storage engine. And so Quora is able to translate on the fly and tier out data into Iceberg, and then read it back and translate it back into Kafka data for consumers. So what do we call this functionality? We call it table flow, right? This is the flow of streams out into tables. And this is a fundamental part of Quora. And we're delivering this in 3 stages. In the first stage, it's unidirectional. Data flows from Quora out to Iceberg, and it's made available via the Iceberg format. In the second phase, it actually works bidirectionally, so that now Quora can actually feed consumers off of that historical data in Iceberg. You don't need to have any kind of direct retention. And in phase 3, we're actually moving beyond that. So whether the data came in through Cora, came in through Confluent Cloud or not, we want to make any Iceberg data, whatever you have in your lakehouse, accessible through Kafka. So if you create new derived data sets, those can also be subscribable. And you can think of this as powering certain types of reverse CTL, where data wants to come back out of the lakehouse and flow out to applications. And of course, this makes even more sense with what we just announced, the freight clusters. Those are built very heavily on the underlying object storage, S3, and they're targeting this kind of large-scale deluge of data. And of course, one of the uses for those large-scale deluges of data is to take it out to your lakehouse. And Tableflow makes that incredibly easy to do. And so, we think that when you put all this together, this is the best way to get instant structured data to the lakehouse. You don't have to choose anymore. The stream is the lake. And I think the key phrase here isn't just instant. It's not just the real-time part. It's also about the structured data. After all, when I talked about the problem, that was a big part of where the pain was. And that brings me to the next layer of the stack that has to support this, the governance layer. And here what we've done is take the underlying schemas that are in Confluent Schema Registry and built a mapping into Apache Iceberg. And this becomes the contract for feeding data into the tables that are in the lake. And the propagation of this is automatic. You don't have to go and create a mapping. It's not hard-coded in some Spark job. It flows automatically out of the schema that you've defined. But more importantly, it evolves with that schema. So as new events come, new columns can be added to the table. And most importantly, it respects the compatibility rules that the schema registry enforces. So if a new application comes and wants to make an incompatible change that would break all your warehouse data, that's caught not when the data lands in the lakehouse, but in development, where that schema fails to register. And that's the most important part. That's the part that makes it safe. That's what allows us to shift left that fundamental definition back up to the application teams that are ultimately creating this data, who ultimately own the definition of it, and make it so that they're the ones who are responsible for that evolution. And I think that what that allows is a really powerful thing. It allows what Sean talked about, making your data products truly universal, accessible across both the S3 ecosystem of the lakehouse and the Kafka ecosystem, and acting to really unify both the operational and the analytical estates. But to really complete that picture, it's not enough just to do it for the data. We have to do it for the processing as well. And that's where the last piece of the puzzle comes in, the unification of batch and stream processing. And at heart, this comes out of the capabilities of Flink. Flink has done an amazing job of providing semantics where you can actually build something against data at a point in time, write a query that queries your data set as it is right now, but take that query and run it against data as it changes. And the query doesn't just produce one static set of results, it keeps evolving. And you can do that with programs as well. And so it's taken what was a batch language SQL and generalized it to real-time streaming. And by applying that in this same world, we now have something that generalizes batch and streaming and will work with these both tables and streams. But to make it really true, we have to actually provide that support in Confluent Cloud's Flink engine, and that's what we've done. We've made it so that you can process historical data directly off of S3, reading right out of Iceberg, taking advantage of the columnar format to prune out the data you don't need, using the efficient column compression so that it's highly efficient. But then as you come off the historical data into the real-time world, as you come on to that stream of what's happening right now, you automatically translate over to Kafka and start processing the real-time stream. And so this actually gives you the best of both worlds. You don't have to think about this in the program you're writing. It does it for you. And this allows you to be both fast and efficient. And it eliminates a lot of what you would see in terms of the kind of jerry-rigged Lambda architecture things where you have to write one job that processes the historical data and one thing that it runs in real time and somehow stitch that together. This happens automatically in the infrastructure layer. And it allows you to do your development on the rich historical data sets that you would maintain for a long period of time, but then be able to deploy it and run it continuously on the stream. So I think that ultimately the goal of this is not just to open up data to Flink. It's actually to open it up to the rest of the world, right? We want these iceberg tables to be accessible by everything in the analytics ecosystem. And that's why as part of the launch of this, we've done this not just with our own offerings, but with a whole set of partners. Technologies like AWS's Athena, or Snowflake, or Starburst, open source technologies like Spark, or DuckDB. All of these can access the data that is available from Tableflow. It's an awesome set of partner technologies. And the advantage of this is really compelling. I think this is the best way to get data into your lakehouse because data arrives in real time. You can now get data with just a few minutes of lag. You can apply transformations that happen continuously. So if you need to apply some logic to the data to get it into the right format to make it accessible, that can happen as data flows into the system. And you can eliminate all the painful, error-prone mappings that you had to maintain by hand before. That's shifted left back up into the definition of your data products. So this makes life much better for the users of the Lakehouse. But it turns out it's also better for the data streaming platform. It's also better for the users of Kafka. Suddenly, they get infinite retention of data essentially for free, because you were going to keep that data anyway. And it's more efficient when it's stored in Iceberg because of the column compression. They get the ability to do reprocessing on large historical data sets highly efficiently. And all of the table maintenance functions like compaction become more efficient because that's built into the Lakehouse infrastructure. So I think this is a really powerful feature across both of these areas. So let's take a look at actually doing this in action. Everything I described sounded pretty complicated, right? There's all these real-time streams, and there's Kafka, and there's Iceberg, and we're going to somehow translate between them. So what do you have to actually do to do this? Well, it turns out it's not that hard. Ultimately, if I have a topic that's in Confluent Cloud, all I need to do is just click that button. And once I do that, data immediately starts flowing out to Iceberg. It uses the schema that I've defined. It gives me a REST endpoint for the Iceberg catalog, for the tables I've created, that I can take and use with any other technology. This is really technology that is so easy that even a CEO could use it. And I think that's one of the cool things. Whenever you build a cloud offering or any hard distributed system, your goal is to take all the depth and turn it into something very simple, like a checkbox, where it becomes very easy for any customer to use. But of course, our goal with this isn't just to get the data into Iceberg. That's not the end in its own right. Our goal is to use this with other tools. So let's take a look at how we do that. So it's actually not too hard. So what do I need to do? Well, I need to take that same REST catalog endpoint, and I need to take it out to the tool I want to use. So this is Amazon's Athena. And I need to configure it to know about a new catalog of tables. And to do that, I have to give it a little bit of the authentication information. I have to give it access to the catalog URL. And once I've done that, once I've actually put in that configuration and saved it, now I can just go into my notebook and develop against those tables as if they were any other table. So I can list the tables I have there, and this will actually show me the data that was originally a Kafka topic. So now you can see what was a Kafka topic is also a table in Athena. And I can query it just like I would any other table. But of course, my goal wasn't just to be able to apply one tool to these data sets. So let's try and do the same thing now in Snowflake. So in Snowflake, I need to register the catalog in some sort of complicated SQL at the top to tell it where these new tables can be found. But once I've done that, then I can query that same data set in Snowflake's SQL engine and get results instantaneously. So I think this is a really cool and powerful thing. Now I have something which is both a real-time stream, which is subscribable by applications, processable by Flink, but is also available in my Lakehouse populated continuously and available to my analytics ecosystem, tools like Athena and Snowflake. So I think it's an incredibly powerful feature, and it's something we're really excited about. And I think it has some big implications. I think it actually changes a little bit how we think about streaming. You know, if we were to go back 5 years, and you were to ask a technologist, you know, what do you think about all this streaming stuff? And if they were aware of Kafka and some of the stream processing technologies, they would probably say, oh, you know, it's really cool, it's great, but ultimately it's a little bit of a niche. It's kind of on the side. It's good for some use cases which, you know, have to be continuous or real time, but most of the real work is in batch. It's going to happen in the data lake. Most of my most sophisticated processing of data, that's going to happen at the end of the day. That would be a relatively common attitude. But if you think about it, that's actually a little bit funny. It's a little bit unusual. Why? Because businesses are something that happen continuously. Reality happens in real time. It's going on all the time. Any business is generating data from the products it creates, the customer interactions, everything that happens across all the software applications. Why wouldn't it also react and process those things in real time as that data is created? Why isn't that the way it works? And if I asked this same technologist that question, I think they would say, well, yeah, theoretically, maybe it should work that way. But there's a set of inherent limitations that make that impossible. And you know, those would be things like transactional correctness. The database I use, it gives me transactionally correct results. I can depend on it. Or maybe they would say, you know, traditional processing of data is just more efficient. Or maybe it's easier to use. And in fact, if we were having this conversation 5 years ago, they would be right. Many of those things would be true. But where they were wrong was in thinking that these were inherent limitations. And in fact, that's not the case. In fact, those weren't inherent limitations at all. They were just limitations of the current state of the art at that time. And what's happened as the technology has gotten more powerful is each of these, you know, supposed limitations has been checked off. Both Kafka, but also Flink has strong transactional semantics. It can be highly efficient, and some of the largest data processing jobs in the world are built on streaming now. And the ease of use has gotten stronger and stronger. But beyond that, what we've realized as this area has developed is that when we do streaming right, it's not just a niche which sits on the side. It's actually a true generalization of the capabilities of a batch data system. And you can actually see that live in the semantics of Flink, this ability to take a program that's developed on a snapshot of data and then run it continuously in real time. And you can see it as well in TableFlow, this ability to take a real-time stream and present it as a point-in-time table. Those two things actually give a generalization of the way we thought about data by bringing it into a streaming context. And this isn't just a theoretical curiosity. It isn't just a technical detail. It's actually really critical to the next generation of applications that are being built now. When we think about what's needed to really take AI into our companies and make it a powerful tool to use, those AI applications are going to be exactly the ones that cut across what we would traditionally think of as the analytical estate and the operational estate. Because they're going to use data in a non-trivial way, like a lot of our analytics workloads, but they're going to do it in a customer-facing way that runs parts of the business and has strong SLAs. It's going to need real software engineering to bring it out to the world. And that requires a new data platform that makes this easy. And that's the data streaming platform. And we think that these three interfaces that you heard about today, these are the key interfaces that bring that platform out to the world. Kafka has become far and away the standard for streams. This is the way everybody gets streams around the organization. Flink is an emerging standard for the real-time processing, the stream processing. And we think Apache Iceberg is the standard for the tables of data that are shared in the analytical estate. And by taking these and putting them together into a coherent platform, that is the thing that we think is going to make the world of streaming accessible to all the applications and companies. And I couldn't be more excited about what that future holds. I couldn't be more excited to explore it with all of you. And that's exactly what this conference is about. So we're really excited to get to bring this group together. This conference was, sold way beyond our expectations, as you can tell by how packed it is, and thank you all for putting up with that. And so, although this is the inaugural conference, it's not going to be the last one. There's a lot happening in this space, and we're going to be doing it again. So we'd like to ask you to save the date for next year. In March 2025, we're going to be bringing everybody back together. And in fact, it's going to have to be a little bit bigger. For one thing, I think we're going to need a bigger room. But for another thing, we want to broaden the set of content that we have. And so what we have done in the US for the last few years is actually broaden it beyond just Kafka. All the Kafka content is still there, but we brought in stream processing, talks about the governance of data, talks about the use of AI in real time, more content on all the applications. And so next year, we're going to be hosting Current. This is the name of the conference we moved to be able to track to everything in the other locations. Next year, Current will be coming to Bangalore, and we're going to be excited to host you all for that. So join me in attending. Woo! And with that, there's a ton to do today. There's amazing sessions the rest of the day. I'm looking forward to meeting a lot of you and learning from you. Thank you all so much for joining us. Thank you very much.